This is question 8, and we have a cuboid, and we know the length, the breadth, and the height, and we have to show that the length of the space diagonal can be written in the form a times the square root of 2, and we have to find an integer for a. It's 4 marks, and if you want to pause the video and have a go at it now, you can do so, but otherwise I will continue. So we're dealing with the space diagonal, and you should know the formula for a space diagonal using Pythagoras. Suppose we have the length A, breadth B, and we have the height H. I'll draw a sketch. So that is A and that is B. Now if we want to find the face diagonal of, let's say, the bottom face, then it's this one, and this is right angled, so we're just looking at the base of it, the bottom face, and it would look like this would be A and B. And we want to find this length, the diagonal. You just use Pythagoras, call this C, so C equals the square root of A squared plus B squared. But then we can introduce three-dimensional Pythagoras, and well, we have this diagonal C is the face diagonal, and we have this is H, so we have that is C and that is H. We can then find, suppose we're going to call D as this diagonal, which is this one. Well, you see that we have a right angle again, and this is in 3 dimensions. So what we then do is we get D equals the square root of C squared plus H squared. But we then find C squared is the square root of A squared plus B squared all squared. So you just cancel out the square root and you get A squared plus B squared plus H squared. And I should have just put this, but C squared, you square both sides of this and you simply get rid of the square root sign on the right hand side. You can either learn this formula or you can understand how to make it up it's totally up to you. But if we'll go back one. Let's use it then. We'll call PM and that is the square root of the length squared, and the length is PS. The breadth is SR. And the height is RM. So the length is PS is 3√3. So we need to first of all get 3√3 squared. SR is 5, so 5 squared. And RM is 2√5. Squared. So what we then have to do is we have to square out the 3√3 and the 2√5. And to do this, we have to use a bit of knowledge about the laws of surds. So this question is combining three-dimensional Pythagoras and surds. So it can get a bit complicated, but up to this point I would give you the first mark and the second. So by this point I would give you 1 mark for the strategy, and the strategy is knowing to use the formula for three-dimensional Pythagoras of a cuboid. The second mark would be for substituting them in and getting up to this point. But 3√3, well, 3√3 is √9 times √3. And if we have √a, √b, then that equals the square root of a times b, or ab. So making a, so then we have √27. Because if we make a is 9 and b is 3, we get the root of 27. So that's going to be the root of 27 squared. Add 5 squared. And it's the same idea with 2√5. 2 is the square root of 4. So let's have √4, √5, and make a is 4 and b is 5. We want a times b under the square root, so that's 20. So we have √20. All squared. And because the square root and the square are inverses or opposites, they cancel out. So that's 27, add 5 squared is 25, add root 20 squared is 20. 27 plus 25 is 52, add 20 is 72. And this is the third mark for this. So we have the space diagonal as root 72, but we have to write it in the form a root 2. So what we want to do is write root 72 in the form a root 2. Now to do this, what you want to do is write out the list of square numbers which are less than 72 in ascending order. So 1, 4, 9, 16, 25, 36, 49, and 64. Now 9 squared, or 8 squared is 64, and 9 squared is 81. But because 81 is greater than 72, we will stop at 64. Now let's find which of these are factors of 72. 1, yes. 4, well, 4 times 18, so yes. 9, yes. 16, no. 25, yeah. Nope, sorry. 36, yes. Nope. And nope. So the highest on that list is 36. So we want to write 72 as a product of two numbers, and we can include 36. Now that equals 36 times 2. And using the rule that root A, root B is A root B, so using this, we then write that root 36 multiplied by root 2. Well, the square root of 36 is just 6. So we get 6 root 2. And in the form a root 2, a equals 6. And you have to include the a equals 6 part, because the question asks you to state the value of a. And that is the fourth mark. I hope you found this video useful. If you have any issues, just leave a comment, but best of luck with the studying, and thanks for watching.